We're here now to learn about Kotlinbots and building our own personal robot library. Let me introduce to the stage Adrian and Carmen, here to talk about IoT.
Hello, everyone. My name is Adrian.
Hi, I'm Carmen.
We're from Guatemala, right here to share a little bit of robots and Kotlin with you.
Robots are awesome, right? Robots can do things, amazing things. They can do things to solve problems for humans or create more problems sometimes for humans. Robots are really amazing. Robots are really amazing, but we can have like simple tasks completely failed.
But what if a robot like a Terminator wants to kill us all?
They will kill us all eventually. Robots will kill us all, I think. Because,
Or maybe not.
well, Terminator or Pacific Rim. Has everyone here seen Pacific Rim? Well, we are in love with robots like Pacific Rim, Evangelion, or Messenger from anime movies. So they're awesome. Robots are awesome, but there is like this idea which means that robots are only meant to be work in a lab. That you have to have a code and a PhD and a big lab with big resources. And the whole idea of this is to tell you that you already have the abilities to have a robot army and have amazing things done.
Yeah, our main goal here is like get you all excited and start to build right away using a couple of tools that we're going to discuss during the presentation.
We're going to talk about how robots are like baking cakes.
Woo, cakes! Who's hungry? Raise your hands.
The cupcakes we had today were amazing, right? So building a robot or baking a cake, you need ingredients, you need to know what you want to do, because it's not the same cake that you're going to build for your mom that you're going to build probably for your aunt, because your mom probably likes tartlets, and your aunt probably likes tiramisu, and it's not the same cake that you have for a birthday party that for a wedding, I think, right?
That clearly is for a birthday, right?
Not really, no. It's like for a wedding, I would think that.
But when I looked online, it said it was for a birthday.
But it kind of looks like a wedding cake, not a birthday, because
Okay.
it has fondant and stuff and fancy things, I think it's. So as a reminder, we have to think about bots. What problems are they solving? So the same thing as cakes. What are we going to celebrate? So we have these amazing tools that are our ingredients to make robots.
And we can bake delicious things like smart meters or smart doorbells, interactive ads. All these IoT products need some design process in order to build them. So although our goal here, it's more like on a maker side of things. I mean, we want to get you all excited. It's important to keep in mind that when you are working for IoT products, we do need a design process. We do need a goal and different kind of things. We're going to discuss here a couple of tools, some ground rules in order to work with electronics, but keep that in mind that this can go from something like building something simple like a hobbyist all the way to build a connected IoT product.
Yeah, and all the tools, you already have them. So it's very easy in a way that you don't have to acquire a big, huge lab with big, huge funds to actually make your robot army. And this is us last week eating baleadas in Honduras. We were last week in a local university in Honduras, and they took us to eat this tortilla made from wheat with frijoles and cheese and cream.
Those were delicious.
They were awesome, they were great, and they were delicious. And this is how we think, we have all the ingredients. So if we mix these ingredients differently, we have different things. So you all have the tools to make different things when it comes to robots.
By the way, we hope you like food. I mean, both of us are foodies. We enjoy having some local plate, wherever we're visiting a city. And that's why we're sharing this picture.
We're very big time foodies, and they told us here in Boston that we have to eat like clam chowder or shrimps and stuff like that.
Yeah, for sure. So, the tools.
Android things.
Yeah, of
It's
course.
amazing, right?
But as Kelly was mentioning, we do need some stuff like a wheat tortilla, beans, cheese. So we will need Android things. That's the platform. That's our like square one in order to build some robots.
And this we have our mini computers, a Pico Pi, or a Raspberry Pi. This is where we start. With this basic thing, we start building a robot.
Right here we have a Pico Pi. It's an IMX7D. Might sound like a mumbo jumbo of numbers and letters, but basically, the single board computer comes with a chip. It's designed in order to build using the board, and afterward, when you have everything ready, the prototype is working, then you can just plug out the microprocessor and put it in your product.
And we have different ways managed by Google or managed by developers. With apps and drivers or Android framework or hardware libraries that you already have. There are a lot of libraries that you can use with code or different ways to actually build these robots.
Basically, the magic here is that if we are already doing Android, if we know the platform, it's really easy to do the transition to build IoT products. There are a couple of things managed by the platform, a couple of things managed by us as developers, and there are many things that are already in the platform, like the same SDK, the same ID,
Firebase, cloud platform, things that you already know and already use every day, and you can apply it with other things like Android and other things, and Play Store. And there's no Play Store, so we can actually build better things.
So summarizing a little bit about Android things, we do have a lot of similarities with the Android SDK platform developing for mobiles, that is. And also, we have a couple of things that are different. No Play Store, an IoT console. We can do over-the-air updates. Keep this in mind as we work our way with all the stuff that we're going to review today, because that's our start. At some point, I think Kotlin native will be ready to work directly with the hardware, but right now, we do need this layer of abstraction that's Android things.
So first of all, we need to work with a breadboard or a protoboard. And we also need this. This is like the example for the work, and we have all of this, how they look physically. But where we're starting here is if you can actually turn on an LED light, you can do it. I'm not an engineer. I'm not a developer. I want to make that clear. I'm a graphic designer, but I'm a graphic designer that works with humans. I solve problems for humans when it comes to something like an objective of selling things. So if I could do that, knowing a little bit of Kotlin, you can sure build an army and probably kill us all.
So how many of you have any experience with electronics? Raise your hands. Oh, so this is going to be easy.
This is going to be a piece of cake, then definitely.
So this is a circuit. Maybe you remember that from your electronic classes or something. And this is the representation, the schematics. I'm just reviewing this pretty quickly for the people that didn't raise their hands. And although we're comparing this to a circle because it's like a closed loop, it's important to keep in mind that we have the battery, BCC, 5 voltage, whatever you want to call it, and ground. And in the middle, we will have some electronic components. In this case, as we're lighting the LED, this is the hello world for electronics. We'll have a resistor and the LED. Let's get to a...
So remember that depending on how you add the ingredients, you get different things. This is an anafre. An anafre in Honduras is still tortilla chips, harina tortilla chips, or wheat tortilla chips, beans, frijoles, and cheese. But it doesn't look at all like the baleada we saw before, right? Because the way you order and organize the ingredients, you'll get different things.
This reminds me, the first one I went to France, I like burgers. So I took my huge burger with bacon, cheese, and everything with my bare hands, like I'm used to do it. And people stare at me like, whoa, what are you doing?
You're a prehistoric man.
Yeah, something like
eating
that.
burgers with hands. So it's also knowing how to build things that is going to help us do it.
So as almost everyone in the room have some experience with electronics, this is going to be quite easy. We need to measure things. So we have volts, amperes, and ohms for electrical potential, current, and resistance. And all these three are related through the Ohm's law. We also need Kirchhoff's current law and Kirchhoff's voltage law. Basically, this states that the algebraic sum for any node would be 0. So everything that goes in eventually needs to go out. And with the voltage law, we are analyzing the drop of voltage on each part of the circuit. These three laws are the basics that we need to understand in order to work a bit with electronics. As many of you already have experience with this, we're going to go right away with the LED.
this is what I built. I'm not a developer like I said before, but I could build this. And if I could build it, and I have very little knowledge about this compared to you, you can do the rest of the things. Here we have the breadboard, we have the LED light, we have our different things. And it's important, just as we need ingredients to make a cake or to make a baleada, to make everything, we also need things to make it with. We have our pico pie.
So that's the pinout. There are a couple of configurations depending on the jumpers. In this case, we're going to use, actually the screenshot is a little bit outdated. The names of the GPIO pins change from 0.5 developer preview to 0.7 or 6. I'm not sure which one is the last one. But the main idea here is that we have our single board computer, and that's the pinout. We're going to grab a couple of pins, in this case just one, the GPIO 32 just below the PWM on the left, and plug that to the LED.
Here, 32, right here. And this is where we have the computer and the breadboard, and we are going to add a resistance and the LED light. So here we're going to describe brief, two of the ways that you can actually use Kotlin to write this, through GPIO and PWM.
So there are many ways in which we can interact with the peripherals using Android things. The easiest one is the GPIO, general purpose input output, is only one pin. It can be an input or an output. You need to configure that using software, and two possible values. It's digital, so basically we just say this is an input or this is an output, and the value is going to be high or low. It's not the only one way to interact with the peripherals, but it's the easiest one. And we're going to use that in order to light the LED.
Another thing we need is software. Software is the knowledge to how to do the things and how to do the things with the hardware. We have to mix both to actually make it work. So first we're going to use the build grade that is going to be Android things, that is going to point out where we are starting right now.
Besides doing this in the Gradle file, we also need to configure in the manifest a couple of things. We're going to use the library, the Android things library, and also we need a special kind of launcher. That's why we have that IoT launcher. And depending on what are we using, we do need some permissions. So in a couple of slides, we're going to see remote control from the phone to the board, and we do need permission like Bluetooth, Wi-Fi, and all of that.
So we're going to start with the GPIO, and we are going to get the managing it, and everything is with that GPIO. We're going to launch a software and tell them what is going to do our bot. So
we're going to use Kotlin coroutines. Anyone familiar with those? Raise your hand. A couple of hands. That's amazing. I just learned about Kotlin coroutines about maybe 6 months ago, and fell in love with both Kotlin and coroutines right away. I mean, I've been struggling with...
That's why it says override fun, right?
Might be.
Maybe.
So I've been struggling with RxJava for a while, and I think it's one of those things that it takes a while to understand, but once you do, you really understand how to do work with streams and everything. But working with coroutines is way easier and also easier to understand. So that's why we have, can we go back one? Yeah, that's just one. Go ahead. Yeah, right there. So, so that's why we have a job, because we're going to blink the LED using a coroutine. And also, we have our variable. It's a GPIO. And as Carlos explained, we're just setting the direction of the pin.
Which one are we using, and how are we going to use it? If it's going to be the turn on or the turn off of the LED light, and that's going to alternating it is going to blink or is going to turn off completely, and we're going to define how much time is going to turn on and turn off.
And over there, we launch our coroutine. It's a function called LED blink, and we're going just to toggle the state and afterwards call the same function. Let's go to the next one.
Then we are going to suspend fun. How come we're going to suspend fun? This is going to, why?
We're having so much fun with Kotlin.
I think so, yes, but why? Where are we going to do it?
We're suspending the function because coroutines work like a light thread. if we use thread.sleep, we're going to stop everything. Instead of that, with coroutines, we use a special function called delay that only stops this. In this way, we're not stopping the whole execution, just this function. So basically, we toggle the state and call the delay function in order to wait for the next execution of the same function. Before that, we're just missing something at the very bottom.
Oh, true. We have, if we are using something first, you have to return it. Everything, if you're using, with GPIO, you have to use one and then return everything you do. It's like when you ask money from the Godfather.
A loan?
The Godfather?
From the Godfather?
Of course, you have to return it. You have to return it Monday, Tuesday, Thursday, Wednesday. You have to return what you're using. You have to return the energy that you use or the pin to be enabled to be used again.
Yeah, this is quite important. So basically at this point, although most of the audience already have experience with electronics, I'm guessing most of you already did this. This is a magical moment. The first time you light an LED.
It was for me, definitely, because I had never done it before. And when I did it, it was like, oh, yay, I did it. I made it. So now I can build an army.
So at this point, you feel like Prometheus. Like, I just stole the fire!
Come on.
So
Take it down. Take it down a bit.
but
It's
I'm
just a
excited.
LED. Yeah, but no.
You should all be excited too.
Maybe.
Okay, so basically, that's all that we need to light an LED. It was a couple of steps. Summarizing, we do need some hardware and some software design. That's important to keep in mind because if anything fails, we need to do the debug process, but now we need to debug 2 times. And debugging hardware, it's a bit more difficult. We need a multimeter in order to measure things. In this case, it's really simple. It's a simple circuit, but it's not that different from debugging software. So hardware, software, we plug everything together, and boom, we have an LED.
And now we're going to, if we could do that, we can actually power an motor. In this case, we're going to power a servo motor because it's basically the same thing, the same type of code, the same type of instructions, the same thing that you got to use one pin and then return it. So we're going to start doing robots with that, right?
For sure. So in order to work with the motor, we're going to use a different kind of way to interact with the peripheral. Instead of using GPIO, we're going to use
PWM.
Yeah, that's right. So what's the deal with PWM?
It is analog, so we have to define what are we using. Instead of GPIO, that is digital, that has 0 and 1, or true or false, in analog, we have to measure how much are we going to send, right?
Yeah. So here we have GPIO, PWM. Let's continue to the next slide. And
GPIO uses only one pin, so it's only output. So PWM is only output, it's analog, like I was saying before, so we can power motors.
And in order to see that in code, we again have a variable. In this case, it's a PWM variable. Again, we open the pin, and let's continue to the next one. And we're going to configure the duty cycle. So we do need to do some calculations, but it's basically just saying we're going to modulate the pulse width in order to move the gears of the motor.
How strong the pulse is going to be, how long is going to be this pulse, and when is it going to stop. That's where we're going to define in this part.
And again, we're using a coroutine. So let's see the code of that coroutine. We're checking if the pulse is increasing or decreasing.
That's about how long is it going to be, right? It's how long is going to be, when is it going to stop, and also how much is going to last, like I said before.
So at this point, I think we can try the demo. Let's see if it works.
Yeah, I think we can. I'm going to unplug this thing.
Okay. Maybe we can switch places. Oh, look out.
I'm going to die here.
And live demos are always fun.
We're going to see if it actually works right now. Because moving everything from one place to another is kind of complicated, but we actually made it.
So let's see. To Android Studio. By the way, all this code is already published on my GitHub. So you should be able to access it right away. And here we're doing several things. There's an LED. You have to trust me because it's
It's right here.
it's right here. And
So,
maybe with
I don't know
some
if you
shade.
can actually see it, but it's blinking. It's the same function that we used before. It's the one that's going to power the servo motor that is actually here. It's the same code. It's the same thing, just the application is different.
And oh, it failed. But it was running from before. So I'm just going to uninstall it and wait for a second. Go ahead and tell one of your jokes.
I'm not going to tell any joke right now. Well, first of all, another thing that I want to add, this is the first time that I'm actually giving a conference in English. I've been giving conferences in Latin America, Colombia, Honduras, and Guatemala. I'm a teacher in university, so basically you popped my cherry. Because I've never actually given an English conference. This is actually very new to me, so I'm really excited, and forgive me if I'm a little bit nervous about it, but I'm really excited to be able to share this from the perspective of how to design something and knowing the design process and how to apply everything you know into something as awesome as robots.
Okay, so I'm going to switch again. Sorry about this. We're living in a dongle age. And I only have one USB, so nothing to do. And although we already discussed that,
We discussed this already.
paying
so
the loan to the Godfather, it's quite
yes,
important.
Yeah, remember always to pay who you owe, and in this case, we have to return the pins that we use.
And besides that, besides all the peripheral I/O that we already saw, we have the GPIO PWM with a couple of samples. There's also I2C that we're using with a different project that we're going to show at the very end of the presentation, SPI and UART. These three allow us to connect more devices, and we're not covering them in this presentation, but feel free to check them out. Besides that peripheral I/O layer, there's another one about user drivers, because building by ourselves all the calculations in order to move the servo, it's a bit complex, or
It's complex, or it takes a longer time. So there are drivers that already exist that we can use to facilitate our time and production.
So the code you saw before can change into this. We just need to define the pulse duration range, the angle range, enable the servo, and after that we can set the angle, and basically that's it. We're moving our servo.
We can move the servo with that. We just have to, depending on how we use the pulse, it does different things. So we're going to suspend fun again?
Yeah.
Okay.
Keep in mind, coroutines allow us to do the delay stuff. Let's get to the next slide. I was supposed to be there, but those three dots on the very bottom includes a delay. That's the magical thing about coroutines, because we can work the servo movement and the LED link, as you saw before, in the same program without stopping everything. And finally, we have a peripheral driver library with several drivers developed by the community. And
This is the great thing about Android things. That there are a lot of things that the community builds that we can use to build, because this is one of the most important parts. So we have this amazing little thing that's called a rainbow hat that has numbers, it has buttons, it has a buzzer, it has rainbow colors, like the LED are rainbows. We can plug this into a pickup wire and do a lot of amazing things.
And as it comes with a sensor, we have this sample. If you at any point work with sensors in Android, it's exactly the same. That's really cool. We just need to register to the sensor manager. Then, let's get to the next slide. Register the temperature sensor in this case. By the way, if you are building a product using that sensor on that hat, it's a terrible idea.
The rainbow hat, it has, the CPU is very close to the sensor, so the sensor might get wacky, because if the CPU gets hot, the sensor is going to kind of like not work properly. So even though it's an amazing way to work, to use the sensor, the rainbow hat is not necessarily the best.
But don't get us wrong, the sensor itself it's really
it's amazing.
good,
It's
but
really good.
just the way it's located on the hat, basically a hat is just for learning and prototyping. So if you're working with an IoT application that involves temperature sensing, use the same sensor but connected in a different way. So yeah, we just wait for change on the value, and that's it. We have our sensor.
And the sensor works in the end.
And that's a couple of drivers that are developed already. There are many more, and you just need to import those in your Gradle file in order to use any of those electronics. So that's the basics. And we can build something more. In this case, we're building a couple of vehicles. We have one right here. It's called a SumoBot.
This is the one to fight. This is the starting point of fighting bots. The SumoBot is a really small bot with two wheels and a crazy wheel that moves forward or backward depending on how you program it.
So we need two things. The first one is a way to control it remotely.
There's our remote control, and we need a way to connect it.
And for that, we're going to use the Nearby Connections API. So basically, we have a chart here. Let's go to the next slide. One of the parties needs to advertise. The other one needs to discover. We're going to advertise from the Pico Pi and discover from the cell phone, and eventually accept the connections.
This actually means that if I ask you who wants candy after the conference, I am the one who's looking, and you are the one. If we actually do have candy for you after the conference. So who wants candy? Guatemalan candy?
A couple of hands.
A couple of hands? Yeah, sure. So we'll give it to you later. That you are discovering, right?
And eventually, when we have the connection accepted on both sides, we can send a payload. In this case, we're sending a simple payload. It's sent as bytes, where it's a string, in order to choose the direction of the movement of the vehicle. So we need a things app for that. We, again, need to import to the Gradle file the library.
The library that we're going to use. And this time we're going to look for something. We're going to ask for something, right? We're going to ask what do we need through, in this case, Bluetooth.
Keep in mind, the Nearby API, it's a layer of abstraction that allows us to connect, but underneath is going to use maybe Bluetooth, maybe Wi-Fi, and that's why we have all this.
Depending on what you have, you can use either Bluetooth or Wi-Fi to connect to your robot, in this case.
Then, for the connection, we just need to advertise, as we said before. In this case, we're using a strategy of P2P star, although we're just using one party on each side. I mean, we only have one remote control and one SumoBot for the sample. And we need to accept the connection. Eventually, when the connection is accepted and the status is OK, then we stop advertising, and we can proceed to the message interchange between these two parties. And finally, we need to parse the payload. As I mentioned, it's a simple, really simple payload where we have forward, back, left, and right, and stop, in order to control the vehicle.
For that, we are going to use a mobile app. Again, we are going to need to use the library. And again, we are going to give permissions from the, this is the other way around. Instead of the remote control in the robot, we're going to have to give permissions. And Bluetooth, Wi-Fi, depending on what you're wiring it with. And the robot is going to respond to callback. So if we were telling him to go forward, go back, to stop, to turn, to everything, we are going to do it through the answering the call.
And as we mentioned before, here we're doing the discovery. The process includes accepting on both sides. So in this case, we're checking if the status is a success, and then update that status as a message on the app. Let's get to the next one. So that's for the communication, for the Nearby API. Besides that, we still need to move things here. So I'm going to unplug a couple of things, and please continue with
This is one of the things that is very cool about this. Remember that we told that robots are not exclusively for labs, for big labs, for big things that we need a lot of budget to build. This SumoBot is around, like $35 that you can get, around $35. And there are blueprints that you can download, either to print in 3D or to have them laser cut on, like this one, that is laser cut on wood. So it's not a necessity to have a lot of money to work on these things. And another thing is that you can buy things in China, thankfully, very cheap for $5, $10. So you don't need a big budget to work these kind of things.
So let's see if this works. Another live demo, always exciting. I'm going to switch to a different project. And of course, I should plug it in first.
This is the thing about live demonstrations. You have to juggle with a lot of things.
Luckily, there's two of us, so we can...
Yeah, but your computer only has 2 hubs. So nothing to do there.
What I was saying that I gave live demos before, and it's a bit of a stressful time when you are speaking and doing something. At least you can juggle with balls.
Not really, no. I can't.
At least you can try.
No, I won't. I might hit you in the head with a ball.
Why? I think that's supposed to be working. Let's check the log. And I'm not sure if those are...
There it is. So
Let's
the
move
one
it
that is
down.
working is the one on this side.
Okay. Just wait a bit. And I have the app running on my phone. Hopefully it will work. I also have a hotspot running here, so let's stop that. And it's not advertising. Let's see. Let's try to connect again.
And so the wheel that is moving is the one here.
Just in case it doesn't work, we can keep going with the presentation as we have limited time, and I will try to run this again in a while. So this is waiting for an endpoint, and this doesn't seem to be working. Let me try one more time, and if it doesn't work, we'll continue with the slides. And it seems like we're missing something. Okay, let's continue with the slides. And so when I unplug the remote, I unplug everything, it seems. Nope. Let's try this again. Nope. Okay, there we go. Or at least here.
Yep.
Everything seems plugged in here. Maybe. Okay, great. So, meanwhile, we're going to explain a little bit about the servo bot. Try it just one more time. Nope. No, it didn't work. So, this SumoBot, it's built by a member of the community, of the JavaScript community. They have this movement called NodeBots, and it's a simple kit. In order to...
Finally,
it worked.
thank you very much.
Thank you. So in order to build this, we need a special kind of motor that's called continuous rotation servo. So instead of a range between 0 and 180 degrees for the angle, it just keeps continue rotating. And if we want to stop the movement, we set a 90-degree angle. Otherwise, we can set a 0 or 180 degrees in order to move forward or backward. So that's why we have this configuration right here.
Also, how long it works, and depending how we work on it, is going to stop or go forward or go backward, playing with 2 servo motors, right? Because if we go forward, we could put 2 motors to go in the front. If we want to turn, we have to put 1 to the front and 1 to the back, right, to make it turn.
And basically, that's the code that we need. It's quite simple. We just need to configure the servo, and then add 1 for each wheel, and also add the connection. That it didn't work in the live demo, but afterwards we can control it from the phone. So that's the SumoBot. And this is the methods that we use to move back or right.
So we also need an H-bridge to move. This one is a coil motor. We need to use an H-bridge in order to make it work, because it's different from the one that it's a servo motor.
with the DC motor, the thing is that it's way easier and cheaper to build something. But we do need the H-bridge because it works with a coil instead of a couple of gears. So it's easy to get a H-bridge from China, any provider actually? Maybe
China can get it like $10, I guess.
no, way cheaper. Just the H-bridge?
Really?
Yeah, just the H-bridge around maybe a buck or
$1.
Yeah,
Okay.
$1.
I think it's gonna be more expensive to actually ship it here
Yeah.
than the H-bridge.
So, if you were able to light the LED, you will be able to control the DC motor using the H-bridge. We just need exactly the same code. We're using 2 connections instead of just 1. But having 1 on true and 1 on false will move forward. Switching those move backward. And both on false, it will stop the movement. And we just need to configure, like we did with the LED. Both connections are out, initially low.
And that's how we add 4 of these motors, and we can have a robot with 4 wheels.
Okay, so we have a couple of videos that we would like to show. The first one is regarding Norberto the spider.
This is a kind of an ant because it has
Only 6 legs.
6
instead of
legs,
8.
but it has 18 servos to make it work.
But I want to call him a spider.
It's not a spider. It doesn't have 8 legs. You can't call it a spider.
Each one of the legs comes with 3 different servos. So one, it's the movement of the, I don't know what's the right plural for this word, like the coxa. The other one will be the femur, and the other one the tibia.
If we look closely, we actually have 2 hats in the top of our mini computer, the PicoPi, because we need 18 pins, and one only has 16. So that's why we need 2 hats to make it work.
By the way, these hats are being controlled by the I2C, so we can stack up to 256 different ones and control that times 16 servo motors using the signal of the I2C. So this is still a work in progress, so we would like to show you.
This is how Norberto walks. So this is how Norberto walks. It's turning. We can see how it turns and walks to the front. It's still a work in progress because most of the things is like trial and error. How it works, how many potens you need, how many string you need to make Norberto, in this case, walk.
Walking is difficult. That's one of the main takeaways that we got at this point. Even though it still seems a bit weird, we've managed to do the movement. I mean, at some point it seemed like it was a bit drunk.
At the beginning, the legs didn't have enough power, so it wouldn't actually get up. It would stay like sleeping. It's like, I don't want to work, he said. And then we needed to power it more to actually make it walk like this because you need energy to keep the servos up.
Yeah, this uses a lot of current. So we switched to a different battery. We switched to a different strategy for the movement. But we do need to move each one of the servos when walking. And overall, this is still a work in progress. Although we review a couple of things, the basics are quite approachable, I think.
Most of it, you already know how to use these things. Just need to apply it in a different way to make, in this case, like us, make Norberto walk.
And here we have a couple of other things that we're working on, like a biped. We're using 4 servos here. It's 3D printed, and for some reason, I don't know if you can see on the right-hand side, the left foot, it's for some reason, always the same part, it's
It probably is a design failure because it always, whenever we try to make it walk for a little while, and then it breaks that part, always the same part.
And a couple of projects using, I really like the LEDs. These are called NeoPixels. You can, with just one channel of data, control several LEDs. In this case, it's a matrix. And it's a tic-tac-toe game. And finally,
we have Tetris. also built in the same way with LED, because why not? Having a Tetris built with LED light. It's awesome, right? Because Tetris is amazing. I love Tetris. And having it this way and actually programming to make it work like this is amazing.
So basically, these are different ideas of projects. We are working more on the maker side of IoT. I think it really depends on what are you looking for, but our main goal here was to get you all excited. I think we have a couple of minutes to go, and I'm going to try again to work the demo. But basically, we're looking to just leave a spark with you in order to eventually ignite a blaze. Building robots is for everyone. We should be able to experiment and learn, regardless of if you're looking for something more on the hobbyist side or you're looking for building an IoT product. It's important to keep in mind that we do need a design process. We need the right tools, like when baking. And hopefully, you all will get excited at some point and try any of this at home. Please do try this at home. It's quite easy to get started.
The tools, you already have it. The hardware, you can get it. Everything you need is very accessible. It's not like they say that it's always in a lab, that it's always only people with money. We can do this thing. The whole idea of this presentation was to actually make you excited about building robots. It's not as far-fetched as we all think it is.
So that was it from our side. I think we have like 30 seconds for questions. If anyone is interested in seeing all the things and maybe the demo working, please approach. Or if you want candy, please approach to the stage.
And we can try to make it work outside because the time frame is a little smaller. So you can actually see how the motors work. But from our side, this is all. Thank you very much.
So, thank you.
Any question?
Hi. If I was going to get started with a Android Things project, what are the key differences between the two processor types? Are there differences in like performance or capabilities, or like which one should I choose and why?
There are many differences. Actually, it also works on another one, on the IMX6. I would recommend the PicoPi. It's a bit more expensive, but you can use a USB port for both debugging and powering the board. With the Raspberry Pi, you only have a regular USB to power the board, and you need to do wireless debugging. That's sometimes a bit wonky. So that's why I prefer to work with the PicoPi.
And with the Pico, can you just take your app and move it between the two platforms as long as it runs on Android Things?
Yeah.
It'll be compatible on any sort of board.
Yeah, you need to change a couple of things like the names of the GPIOs, but basically the pinout is the same. The idea of the boards is that all three, but basically these two are compatible in almost everything.
Thank you.
All right, so this looks like a blast, playing with these things. And certainly the software is not expensive. Somebody could set up their laptop and tools and get going and start writing code. Now, one of the things I'm curious about is how much capital do you need to invest in? I mean, do you need an oscilloscope, or do you need any other tools for the hardware? And do you need to invest in lots of hardware because you brick some of them quite frequently? I mean, can you talk to that a little bit?
Well, it really depends on what you're looking for. What are you looking for to build? I mean, you don't need an oscilloscope for this. You need a multimeter. I have my background is on CS. I'm really clumsy with my hands. That's why I didn't study electronics. And I have connected everything wrong like many times, short circuit and everything, without causing an issue. I mean, so you don't need like buy 5 PicoPi or 5 Raspberry Pis. You will need several components depending on what you're trying to build, like sensors or any other things such as the hexapod. That kit is quite expensive because it comes with 18 servos and the whole structure, it's around $700. But if you're looking just to start with and maybe build, I don't know, a weather station, you just need like the sensors, some packaging that could be 3D printed. So it depends on what are you looking for, but I would recommend to get the basic tools like a multimeter, maybe something to check the logic states, and a couple of components. You can even get a kit from Pimoroni, that's one of the vendors, that comes with the hat, the PicoPi, and a screen, and it's around $100. And they are giving away those like candies and several Android events. So yeah, it's easy to start with.
Just to add up to that, we are from a small country in Central America. One of the things is that resources at universities and local schools are very small, are very limited. So everything that you break, you can actually fix it, just pin it back together. And nothing actually burns, nothing actually explodes. So we are used to work with small budgets because Guatemala is a third world country and our currency is not really good. So it's not really expensive to build those things back home, because even if a pin breaks, you can solder it back together. So it's not a question of budget at all. That's the whole idea of this conference, is that it's basically just to save a little, and with $50, $100, you can actually build one of these things and play with it.
Any other questions?
That's about all we have for time at the moment.